Good morning, children. Today we are going to discuss a new chapter called surface area and volume. Okay, I think everyone knows about what is called surface area and what is called volume. When we talk about surface area is nothing but the total space it occurred, by a particular object. Yes or no? How much space it requires. Now, when it talks about the volume is the capacity. Okay, how much it can hold. For example, we have any particular box, how much materials or how much structure or how much materials it can hold in this particular box. We set it to be the capacity or the volume of that particular box. Clear? Before moving ahead in detail or solving the exercise problem, we need to look into few, diagrammatical or geometrical representations and see how the structure look like. The first is the cuboid. When we talk about cuboid, you could see this is in the form of this particular form. Now, surface area of a cuboid is 2 into LB, length into breadth, plus breadth into height, plus height into length. That's what the surface area of a cuboid. When we talk about, let's say this is a particular small box we have. This is in the form of a cuboid shape. This has the length from here to here, length. Here to here, this is the breadth, and we have the height as well. Okay? This is length, breadth, and height. This is what the cuboid look like. Length, this side is breadth, and then the height is this. Clear? This is how we talks about the cuboid. Now, second one. If you see, this is a cone. Cone we know, ice cream. The half part of the ice cream, the down part, it's a cone shape. CSA of a cone is pi RL. Pi we know it is 22 by 7 or 3.14. R is the radius. Here radius means in this cone you could see the top part is in the form of circle and the down part is in the form of a V shape. Pi RL. R is the radius, L is the slant height. This particular part is called L. Okay, it's length height. And how to find the L? L is nothing but R square plus H square, root over R square plus H square. And what is H? H is this particular part, we call it to be H for cone. Clear? Next we have cylinder. CSA means curved surface area. Curved means the outer surface area, okay? CSA of cylinder, that is curved surface area of cylinder, equal to twice pi R. One thing or no, what is twice pi R? Twice pi is circumference of the circle, and we have the height. Firstly, we will calculate, how bigger it is, like this, how bigger it is, the top part, and how much is the height of this particular cylinder. CSA of cylinder equal to 2 pi RH. Clear? Next, we have sphere. Sphere means, for example, let's say a tennis cricket ball. Now, this is the sphere. Surface area, SA is surface area of sphere equal to 4 pi R square. Okay, R is the radius, pi we know. Next, if I cut this sphere into two particular parts, we will get this two particular shape. For example, I am cutting a tennis ball into two particular parts. These are the two shapes. Clear? Next, we have this part is called the hemisphere. That means one part is called one hemisphere, other is called other hemisphere. CSA, curved surface area of hemisphere, equal to half of the sphere, half of the surface area of sphere, half into 4 pi R square, we got 2 pi R square. Clear? In order to do the numerical problems of this chapter, you need to by heart or you need to remember all this particular structure and the formula. Clear? Now we will see combination of, combination of solid. Surface area of combination of solid. In this diagram, you see, this is an oil tanker. Let's say oil tanker. You could see oil tanker is in the form of this shape. If I take the tanker and put it here, I could see it is divided into three parts. This is the first part, second, third. I could see this is hemisphere, and the middle one is cylinder. TSA, if I need to find out the surface area of the whole tank, that is the total surface area of the new solid, equal to, what is there? CSA of one hemisphere, 1, 2 hemisphere, CSA of cylinder, and the third is CSA of other hemisphere. Clear? We know the hemisphere formula, we know the cylinder formula, we can just directly add it. That's the total surface area of the new solid. Now, for example, this is another structure. Let's say this is a cone and ice cream. You know, on the top we have the cream, and down we have the cone. Now, top structure is something look like a hemisphere, and the down is the cone. So, total surface area of the ice cream or the structure, we can say curved surface area of hemisphere, the one part, and the noun is the curved surface area of the cone. We know the formula for cone, we know the formula for hemisphere. We will directly add it and we will get the answer. So please go through this topic, try to remember the formulas. Any doubt, please let me know. We will start solving the exercise one by one. Thank you. Have a nice day.